Welcome everybody, it's Ramchandra again from CIVIL-MECH-MATHS Concepts. In this video, I am releasing important MCQs with answers and explanations and their relevance to KPSC and SSC JE, GATE, UPSC, ESC examination and also RRB JE and RBI JE examinations. Please listen to this lecture fully and review, comment, and any doubts you please comment, then I will reply. And please subscribe to my channel CIVIL-MECH-MATHS Concepts, and welcome everybody. And these MCQs are made by me and very important and very thought provoking. Please see this lecture. Best of luck to everybody in their respective examinations. Welcome everybody, it's Ramchandra from CIVIL-MECH-MATHS Concepts channel. Till now, I have released 4 fluid mechanics lectures on important properties of fluids and some definitions. In this lecture, I want to take up 10 MCQs depending upon the lectures what I have given from lecture number 1 to lecture number 4 on fluid mechanics, definitions and properties. Now, let us take the question number 1. My channel is CIVIL-MECH-MATHS Concepts. These MCQs are prepared well for the use of SSC JE, RBI JE, RRB JE, and recent advertisement of Kerala PSC AE, and also GATE and UPSC ESC, Engineering Services Examination. You please try to understand the depth of the questions I made. These are the questions prepared by me only, not taken from any textbook. These are new, and if you practice this way, view my lectures repeatedly, make a notes, and then you try to answer my MCQs. These MCQs are based on my lectures, lecture number 1, lecture number 2, lecture number 3 and lecture number 4 on fluid mechanics, properties and definitions. The first question, if you see, I have asked you to express time T in terms of dynamic viscosity mu, length L and density rho using the Reynolds similitude ratio. What is Reynolds similitude ratio? It depends upon the Reynolds number. What is Reynolds number here? Reynolds number is equal to rho V D by mu. Rho V D by mu. You just see, Reynolds number is a dimensionless number. You please remember this. Dimensionless number. That means RE has no dimensions. From this, we can say rho Vd is equal to some constant Re into mu. Can we write like this? Re is a non-dimensional number. Here we have to use mu, L and rho. We cannot use V and D. What is L length? That is a dimension. V has got a dimension of we can use rho, we can use mu, and we have to convert Vd into length parameters. V is equal to is having a dimension of L by T, that is meters per second, and D is in meters, that is having a dimension of L. Hence this can be written as, please try to understand the concept. When you use Reynolds number, I am using Reynolds number formula. Rho is rho because I can use rho. Vd I can write it as L by T into L, D as L, V as L by T, Re as some constant into mu. Mu is mu. I can use mu also. That means I have used L, I have used rho, I have used T. This can be written as rho into L square by mu is equal to T into Re. Because it is a ratio. I have told you similitude ratio. Because it is a ratio. The Reynolds number divided by Reynolds number, because it is a constant, that vanishes. This can be written as, because it is a ratio, this implies T is equal to rho L square by mu. T is equal to rho L square by mu. This is the answer. Let us see whether answer is there or not. Rho L square by mu, mu L square by rho, it is wrong. Mu rho square by L, that is also wrong. L rho square by mu, that is also wrong. Hence answer is none of the above. The real answer is T is equal to rho L square by mu. This is the ratio of a prototype to the real simulation, because we are using similitude. Similitude is simulation. When we simulate a prototype in the laboratory to the site original design, then the similitude ratio for time will be measured in this form. Hence none of the above is the answer. Please be careful. Carefully read the question. I have to use Reynolds number for similitude ratio. I have to express it in mu, L and rho. I have expressed it in mu, L and rho. Rho L square by mu. As a homework, can you do the same thing? Mu, L and rho only you use, and can you do the same thing homework for velocity? Instead of time, you do it for velocity. Do it for velocity. This is your homework. Do it for velocity. Instead of time, you do it for velocity and show me what is the similitude ratio for velocity. V similitude ratio with Re. RE scale. Please do it. Use only these three parameters. Don't use other than these three. Next. This is on the definition of Reynolds number. I have already defined Reynolds number in my 6 lectures. 2 MCQ lectures and 4 regular lectures where properties and definitions are given. From that only we got the answer. Please try to understand the concepts well. If required, take the review the lectures of concepts again and again, understand them, get the definitions. From that you apply in the examination. In the examination there will not be any direct questions for you. There will be indirect questions like this. How you are able to how you understood the concept and how you are able to apply it in the field, in the real questions. Next, what is Reynolds number? It is the ratio of what? We are very well know. We know very well. Reynolds number is equal to rho v d by mu. But it's not given in this. Rho v d by mu formula. It is the ratio of what? Is it inertial force to gravity force, or viscous force to gravity force, or inertial force to viscous force, or frictional force to gravity force? That means you should know each and every item here. What is inertial force? What is gravity force? What is frictional force? What is the gravity force? What is the inertial force? What is the viscous force? Until and unless you know these force ratios, the force values, as a hint, I will give you inertia force is equal to rho into volume into velocity by time. Inertial force is nothing but m into a. That is Newton's law. M is rho into volume. Acceleration is velocity by time. What is rho into volume is? Rho into volume by time into velocity. Can we write this in this way? Volume by time is equal to rho into a into v velocity. That means inertia force is equal to rho a v square. Please remember this, very very important derivation. Rho a v square is the inertia force. Due to inertia, this is the force, which I have explained already in your definitions and properties. This can also be written as rho a v square is equal to rho L square v square. What is the area dimensions? It is length into length. This is the inertia force. Now next comes, what is the gravitational force? Mass into acceleration due to gravity. This is the inertial force Fy. Fg, gravitational force, is equal to mass into g, mg. Mass is rho into volume into g. That is equal to rho into L cube into g. When we convert into, this is also very 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 important value. This is the gravitational force. This is the inertial force. it is gravitational force. This is the inertia force. Next, what we have to find out? Frictional force. Frictional force is nothing but a gravitational force, because frictional factor is, if I say F, then frictional force is equal to friction factor into mg. Friction factor, that is equal to F friction into rho L cube into G. Now we know inertial force, we know gravitational force, we know frictional force, we know viscous force. What is the viscous force? Now we have to know what is the viscous force. Let us go to the next page, because it is a length. Why I am telling you in detail, so that you should understand what are the forces that are acting on a fluid. Viscous force, because by hearting the formula is different and understanding the formula is different. I can just say what is the ratio, and I will define the ratio, and you people will forget in few days time. Whereas if I explain you in this way, in detailed, then you will never forget. What is the viscous? Viscous force is nothing but shear stress into area. From viscous we will get shear stress. Shear stress is Newton by meter square, that is shear force by area. Shear stress into area is shear force, that is viscous force. What is shear stress? That is tau. Tau into A. What is tau from Newton's law? Tau is equal to mu into du by dy. That is Newton's law. Then tau I can write it as mu into du by dy into A. du is nothing but v, velocity. Mu into velocity by length, y is nothing but length, into area, length square. That is nothing but mu VL. That means viscous force, viscous is equal to mu into V into L. Please remember this also. Derivation also I have shown you. Now, Reynolds number, what is the question? Reynolds number is equal to rho V D by mu is equal to rho V D is nothing but L by mu is nothing but mu is related to viscous force, and rho V is related to rho and V, they are related to inertial force. That means rho VL is related to inertial force and mu is related to viscous force. This is nothing. Reynolds number is nothing but inertial ratio of inertial force to viscous force. This is the answer D. Answer D. Because rho VL by mu is nothing but mu is equal to rho VL is nothing but inertial force by viscous force. If you write it here, what is inertial force? Rho L square V square by viscous force is mu VL. Now VL will go off. that means rho VL by mu. Reynolds number is rho VL by mu. Yes, it has come. Very, 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 very important relation. Very important relation. Reynolds number is equal to rho V d by mu is equal to rho V L by mu is equal to inertial force by viscous force. This you please remember. Now, let us go for Mach number. What is Mach number? Mach number is nothing but ratio of the velocity of the object divided by velocity of sound. Mach number is equal to velocity of object by velocity of sound. Mach number, actually velocity of sound we know 330 meters per second. We see that this what you call aircrafts, they are moving at high speeds. If the speed of the aircraft divided by velocity of sound gives the Mach number. Velocity of the object is spacecrafts, they are also moving at very high speed. Nothing can move beyond the speed of the light, but things can move beyond the speed of the sound. And an object moves at a speed, some speed with respect to velocity of sound. That ratio is called as velocity object by velocity of sound, that is equal to Mach number. Then okay, it is in the velocities. How can I find out in the inertial force to gravity force, inertial force to surface tension, inertial force to compressibility force? How we can find this ratio? Inertial force to pressure? Velocity of an object wherever it is there, that represents, please remember, inertial force. That means ratio of inertial force. In all the four alternatives, inertial force is there. A, B, C, D. Then knowing this alone will not be sufficient. Then we have to know velocity of sound, to which force it is connected. Velocity of sound is connected to compressibility force. Compressibility force. Mach number is equal to velocity of object V by velocity of sound. C is velocity of sound, that is V by square root of E by rho. Compressibility is E by rho. This is the formula. Please remember this formula. Mach number. That means it is the ratio of inertial force to compressibility force. Answer is C. Which of the following is true regarding absolute pressure? Regarding absolute pressure, I have given enough of lectures. In MCQs 2 lectures and also in the 4 fluid mechanics main course lectures, I have given enough of knowledge regarding absolute pressure. What is absolute pressure? You please tell me from basics. P absolute is equal to P gauge, that is measured, plus P atmosphere. This is the absolute. If the range of absolute pressure will be from minus infinity to plus infinity. Just imagine, if you go deep into the physics. Pressure reaching higher pressures is possible. But can we go minus infinity pressure? No, not possible. Absolute is minus infinity means P gauge should be minus infinity. P atmosphere is not going to change. That means atmospheric pressure should be P absolute plus infinity. That means minus infinity plus infinity. If absolute is minus infinity, it is non-determinant. Infinity by infinity, infinity adding to infinity, infinity multiplied by infinity. Infinity multiplied by infinity can be infinity. But minus infinity adding to plus infinity, it has no value in physics and mathematics. And atmospheric pressure cannot be minus infinity or plus infinity. We all die if atmospheric pressure is going to be infinity. There will be nothing in this world. Hence, this is ruled out. The range of absolute pressure minus infinity to plus infinity. Gauge pressure, can it be minus or plus infinity? We can't live under a gauge pressure of infinity or minus infinity or plus infinity. So it is wrong. It is wrong. The range of absolute pressure will be minus 101. For example, let us say P atmosphere is equal to, we know, 101.325. Then P absolute is equal to gauge pressure plus 101.325. Let us say. Then, if the absolute pressure is absolute pressure is minus 101.325 and gauge pressure here plus 101.325. Can gauge pressure be minus 2 times the absolute pressure? It's not possible. Hence, it is also ruled out. Atmospheric pressure, this absolute pressure is minus infinity is not possible. Absolute pressure minus 101 is not possible. Should never be negative. That is the answer. Because absolute is equal to P gauge plus P atmosphere. P gauge cannot go below the datum. I was telling from the beginning. Minus of the datum. For example, P absolute is 0, it becomes 0 when P gauge will be minus P atmosphere plus P atmosphere. That is equal to 0. But if P absolute is less than 0, it implies P gauge is less than minus P atmosphere. No, it is not possible. P gauge can go up to minus P atmosphere, but it cannot go below the minus P atmosphere. P absolute can be 0, but it cannot be negative. Hence, answer is negative. And we will see the other alternate also, D. The range will be from a negative value to a positive value depending upon the gauge pressure. from a negative value. Absolute pressure can never be negative, can never be negative, can never be negative. P absolute can never be less than 0. This is the important. Can never be negative. Can never be negative. If you want, you can see my lectures, read standard textbooks and think over for 10-15 minutes on this question and get the concept clear. Next, which of the following represents one bar? Clearly, I have distinguished between 1 bar and 1 atmosphere. What is 1 atmosphere? From the definitions which I have given in my previous lectures, 1 atmospheric pressure is equal to 101.325 kPa, that is equal to 760 mmHg. 1 bar is equal to 10 to the power of 5 pascals, that is equal to 100 kPa. Hence, which of the following represents 1 bar? 101.325 is not 1 bar, hence answer is ruled out. 760 mmHg is not 1 bar, answer is ruled out. Both A and B is answer ruled out. These are 1 atmosphere, not 1 bar. None of the above answer is correct. Now, which of the following is the commonly measured pressure unless specifically mentioned? I got a pressure gauge, Borden gauge, manometer. In an industry, I measure the pressure. I will say it is so and so. 1 kg pressure, 10 pascal pressure, 100 pascal pressure. That is nothing but the gauge pressure. I am not measuring the absolute pressure. It is a direct question I asked because you have to know what is absolute. I am not directly measuring the absolute pressure with the pressure gauges. I am not measuring the vacuum pressure. Usually, commonly measured pressure, unless specifically mentioned, is gauge pressure. That gauge pressure can be vacuum pressure also, if it is negative. We measure the gauge pressure. If it is negative, then we treat it as a vacuum pressure. It's not that there will be vacuum pressure measuring in instruments. There will be gauge pressure measuring in instruments. Please try to understand this. Answer is B. Next, for a compressible fluid under isothermal environment. What is isothermal environment? T is equal to constant. Iso means constant. Thermal means temperature. Here in isothermal environment, the temperature is constant. And the ratio of final and initial pressures, if temperature is constant, for a compressible fluid, then there will be pressure difference, initial pressures and final pressures. When volume changes, density changes, then what is that? With height also in the atmosphere, atmosphere is compressible fluids will be there, because the atmosphere is full of gases. Gases are highly compressible. Liquid is incompressible. When gases are highly compressible, what is that? We will get the ratio of final and initial pressures. Tell me. The ratio of final and initial pressures. Think over. Think over final and initial pressures. These are all the questions I have taken from the notes I made, especially for teaching fluid mechanics. These are all not taken from any textbook. These are all from my notes. I thought my notes is required. Preparation of notes is required, and teaching from the notes, it will give more insight rather than teaching from a textbook. Now you tell me, which one is correct? In a compressible fluid, we are moving up. I kept that process as isothermal. Temperature is not changing. Then this is clearly answer is this is the answer. P2 by P1 is equal to e to the power of minus g into h of minus hi divided by RT. Temperature is constant, hf is height with height, how it is changing in a comparison, the height, initial, final height and initial height. Why minus g is here? With height, E is 2.718, 2.718 to the power of minus some negative value, that becomes P2 by P1 is equal to 1 by 2.718 to the power of some value, G is 9.81 divided by RT something. That means this relation, gives dP by dH is equal to rho g. From this we got this relation. This is minus rho g. dP by dH. When you measure H in towards upwards, dP by dH is equal to minus rho g. I have told you. Pressure decreases with height when you measure upwards. This is P2 by P1 is equal to less than 1. Implies P2 is some value x. P2 is less than P1. This is very, very important. This I told you already, very important. dP by dH is equal to minus rho g when H is upwards. When H is downwards, dP by dH is equal to rho g. This you please understand and remember it. This is what is written in this form. From this we have derived this. Hence B is the correct answer. Now next. Temperature lapse rate per kilometer of height from earth surface for calculating. Here previously in the previous question it was isothermal. Temperature was not changing. Here temperature is changing. This is the earth surface. When height is measured this way, P is decreasing with height. Height is measured this way. There will be temperature decreasing. The decrease in temperature per kilometer is how much? That is called as temperature lapse rate with height. This is earth. From standard books, it is derived that 6.5 Kelvin. 6.5 Kelvin means temperature lapse rate is 6.5 Kelvin. This is the straight question, straight answer. Now, decrease in temperature, whether it is degree centigrade or Kelvin, it is not going to make any difference. To confuse only, K is given, nothing more than that. Because if two temperatures are there, decrease in temperature means delta T. Delta T means T2 minus T1. T2 is equal to some small T2 plus 273 minus small T1 plus 273. 273, if it is in degree centigrade, T1 degree centigrade. That means it is in Kelvin. Capital T is in Kelvin, small t in degree centigrade. It's not going to make any difference when it is a difference. Find the value of the pressure inside a vessel if vessel is connected with a manometer. There is a vessel. Let us say this is one vessel. This vessel is connected to a manometer. This is the manometer. The manometer liquid differential level is Y2 of relative density SL. That means in the manometer there is some liquid, manometer liquid. This is P atmosphere, manometer is open to atmosphere, and this liquid relative density is SL, and this is the point. The vessel contains a fluid of relative density SF. SF, this is the relative density of the fluid, and this is the height which I have explained you previously in manometers section in the last lecture. Sir, we will make it little bit smooth. This height is the manometer liquid differential level. This liquid is different. This is of liquid SF, this is of SL, this is 0.1, this is 0.2, and atmosphere to 0.2, this SL, this height is Y2, and the fluid in manometer up to depth of Y1. This is Y1. Now, we have to find the pressure P in the vessel. How to find? I told you, come from P atmosphere, treat P atmosphere as 0. If you come down, the pressure will be increasing. If you go up, pressure will be decreasing. That means P atmosphere plus, what is this, SL into Y2 at level 1 and 2, the pressure will be same, is equal to Y1 into SF, Y1 into SF plus P. This is what is the, this is the pressure inside the vessel. This Y2 into rho G, because rho GH we have to add to calculate the pressure. Therefore, pressure inside is equal to SCL Y2 into rho G minus SF Y1 into rho G plus P atmosphere. This P atmosphere is taken as datum and it is made as 0. Then it implies P vessel is equal to rho g into rho g, we will take it as common, SL y2 minus SF y1. This is the answer. Please do it on your own at least 2 to 3 times same problem and get the answer. Answer is D. Then next question is a direct question. For an adiabatic process in atmosphere, because there are isothermal process, I have explained you, temperature is constant. There will be adiabatic processes also where the temperature is not constant. In that case, for an adiabatic process, the question is straightforward. T by rho to the power of gamma minus 1. Gamma is the ratio of specific heats. T by rho to the power of gamma minus 1 is equal to constant is for adiabatic. Please remember this formula. This is the direct question. Now, from these, I have given a mixture of 40% direct questions, 30% and 60 to 70% indirect and little bit thought-provoking questions, so that you should be ready for both the type of questions. And these 10 questions in which we have dealt in very clearly and in detail. For these questions can be of the level from SSC JE to GATE or UPSC ESE, covering everything. This is only about definitions and properties of fluids pertaining to my 4 lectures, main lectures, excluding my MCQs, lecture 1 and lecture 2 MCQs. This is fluid mechanics, lecture number 5. It is only pertaining to definitions and properties. And next I will switch on to fluid statics, where pressure is measured in static conditions, fluid statics. Then I will take up fluid dynamics. Now with this, I feel we have completed definitions and properties. Now we move on to fluid statics. And you see here we have seen similitude ratios, Reynolds number and Reynolds number, various forces ratios, and also Mach number, and also absolute pressure, gauge pressure, and also what is 1 bar, then also what is the usually instruments measure, gauge pressure, and also for compressible fluids and incompressible fluids we have discussed, and temperature lapse rate also we have discussed, and manometer, when a manometer question is given, how to calculate the pressure in a manometer, and also for an adiabatic process in atmosphere, the value, what is that law which is going to govern is temperature by rho to the power of gamma minus 1 is equal to constant in an adiabatic process. And we have discussed about the isothermal process also. And these are all from definitions and properties of fluids. Best of luck to everybody, and think and do the questions. Don't try to just answer them by seeing the first answer as the first answer looks correct, and if you go deep into the answers like what is 1 bar, 1 bar means people will definitely go for this what you call mistake with 1 atmosphere, and they will give the first answer or third answer, which is not good. And commonly measured pressure means people think it's absolute pressure or a vacuum pressure. No, it's a gauge pressure. And also absolute pressure can never be negative, And match number is regarding the sound. Sound pressure question is already given in the 2024. Maybe on match number question can be there in the next year. We are not aware. It's an inertial force to compressibility force. And also Reynolds number is inertial force to viscous force and similitude ratio. These are all nice problems. Please do them repeatedly. See my lecture repeatedly. See my all lectures, 6 lectures, 2 MCQs and 4 fluid mechanics main course lectures on properties and definitions. You will get the clarity how to answer the questions in SSC JE, RRB JE or ESE or GATE examination or UPSC examination. Best of luck to everybody. And I will conclude with this. And next I will start fluid statics. Please view my videos regularly, review my videos, comment for any explanations. I will give the explanations, and please subscribe to my channel so that I will feel encouraged to do further these lectures on continuous basis. We have sufficient time. I will be moving on, and definitely I will give the best possible course lectures to you as far as civil engineering is concerned. Best of luck to everybody. Kindly subscribe to my channel. View my videos regularly. Okay.